Hey people, and welcome to this video. In this video, we're going to be working on the Mathematics Paper 1 for November 2021. This paper is worth 150 marks and the time allocated is 3 hours. Okay, looking at the instructions, make sure to round off to 2 decimal places unless stated otherwise, and the diagrams are not necessarily drawn to scale. You also have a formula sheet at the end of the question. Okay, with that being said, let's get into this video. Question 1.1.1 says we need to solve for x and we have been given a quadratic equation. Okay, so we can open up two brackets and we're going to find the factors of x squared. So what times what gives us x squared? That would be x multiplied by x. And then what times what gives us 24, but that can give us a 2. Factors of 24, really negative 24. Okay, so factors of 24 can be 6 and 4. And we know that one of it has to be negative since the 24 is negative. So you can give the negative to the 6 because it's the bigger factor. And this will ensure that the number that it adds up to stays negative. Negative 6 plus 4 is negative 2. Okay, so that works out. Our factors are negative 6 and positive 4. Okay, so that therefore means that x is either equal to positive 6 or x is equal to negative 4. And remember, the idea is that you have a number multiplied by another number and they give you 0. So it's either that the first number is equal to 0 or the second number is equal to 0. And that is the only way we could multiply them, and then we get 0. Okay, so those are our answers. Moving on to the next question. Question 1.1.2, we have to solve for x, but correct to 2 decimal places, meaning we need to use the quadratic formula. Now, this is already in its standard form since one hand side is equal to 0. So it is in the form of ax squared plus bx plus c is equal to 0. So let's go ahead and get the quadratic formula. And from this, we can see now we can just substitute the values. So we have negative b, and the b value is negative 3. So that's minus 3 plus minus the square root of, and b squared, that's negative 3 all squared, minus 4, and then a is 2, and c is negative 3 as well. So negative 3 all over 2a. So 2 multiplied by 2. And let's find our answers. And when we substitute that, starting with the plus, we get x is equal to, and this should be put in decimal form. So that is 2.1, and the 6 will help this to round up. So that's going to add a 1 to the 8. So 2.19, or x is equal to, and we'll just simply change that plus to a minus, and we get x is equal to negative 0. And that is also going to round up, making that a 9. So negative 0.69. And those are our answers. Question 1.1.3 says we need to solve for x in this inequality. Okay, so this is a quadratic inequality, so we're going to have to ensure that one hand side is equal to 0. So let's transpose that, negative 4. And so we'll have x squared plus 5x, and then that becomes a plus 4 is less than or equal to 0. Okay, and then we can factorize this. Open up two brackets, and we are saying x times x gives us x squared. And now we need the factors of 4, and we don't have to overthink this since everything is positive. So factors of 4 that would give us 5 would be 1 and 4. 1 plus 4 gives us 5. So that's positive 4 and positive 1. And so our critical values, this is like solving for x. If we were solving for x in this equation, x plus 4 equals 0, then x would be equal to negative 4. And in this equation, that would be x is equal to negative 1. So these are our critical values. Okay, so to solve for x, what we can do is draw our parabola. Okay, the parabola that it forms. This will form a concave parabola since the value of a is 1. It's a value greater than 0. So our parabola looks like that. And there's the x-axis. So we can put down the critical values. That's going to be negative 4. The smaller one is on the left, and negative 1, the larger one is on the right. Now, the inequality specifically says that this needs to be less than or equal to 0, meaning when you substitute any x value, it needs to give you a value less than or equal to 0. Now, since it says equal to 0, you'll notice that if you substitute these values, -4 and -1, in place of x, you will get 0, okay, since this was a factor of this expression. So we can just ensure that -4 and -1 are included in our solutions. So now looking at values less than or equal to 0, these refer to the y values, okay, because they are a result of substituting x values. So looking at the y values, we could look at the y-axis and just see where these would be. Y values less than 0 lie over here. So you're not going to consider any parts of the graph above here because those would have y values greater than 0. Okay, so looking down here, y values less than or equal to 0, you see that it would be these parts of the graph. So all through here like that. That's what we have. And we can now just line this up to the x-axis so we can understand where these are. So these are values that are, so compared to -4, it's moving to the right-hand side of -4. So we have values that are greater than -4 here. And if you compare this to -1, these are values that are on the left-hand side of -1. So these are values that are less than -1. So notice how the arrows are pointing towards each other. So that means our inequality can be written like this, because it's really just referring to values that are greater than -4 but less than -1. We can say that x is greater than, but also remember it is also equal to -4, because at where x is equal to -4, it gives us a y value of 0. So greater than or equal to -4 but less than or equal to -1, and that would be our answer. Since these values, they point towards each other, so they really just lie between the range of -4 all the way to -1. Okay, this can also be written in intervals. So we could have also written the answer like this. We can tell them that x is an element of, and it's going from -4 to -1. So it's going from -4 to -1, but with the brackets, we're going to use square brackets since these are actual included values, okay? X actually is equal to -4 and to -1 as well. So you could write it like this or like that. That would be fine. Moving on to the next question. Question 1.1.4, we have an equation with a surd. Okay, so the first thing we do is we isolate the surd. Now the surd is already isolated, so we can move on to the next step, which would be to break open that surd, okay, to square the surd. So we need to square this side, but because this is an equation, what you do on the one side, you must do on the other side. So that breaks open the radical, and we have x plus 28 is equal to, and we need to distribute here. So you can decide to do this as 2 minus x times 2 minus x, but that can take a while. So we can use this method. We square the first term, and that gives us positive 4. Square the last term, negative x all squared gives you positive x squared. And then first term times second term, that would give us negative 2x. And then we just multiply that by 2. So that gives us negative 4x. And let's just transpose. So we can take everything here over to this hand side since x squared is positive here. So this is going to be x squared minus 4x. And when we transpose that, that's going to be minus x, giving us a negative 5x. And then we have positive 4 and 28 comes over, becoming negative 28. So that is negative 24. Okay, so this is what we have. 0 is equal to, and then factorize. X times x is what gives us x squared. And now we need factors of 24 that can give us a 5. Okay, so it is a negative 24. In this case, 6 and 4 won't work because you see that if one of it has to be negative, you're going to have a 2. So let's try 8 and 3. Okay, so 3 and 8. So here we can give the negative to the 8 so that the answer remains negative. So negative 8 plus 3 gives you negative 5. There we go. So this is going to be minus 8 and plus 3. Okay. So now we can solve for x. So it means that x is either equal to positive 8 or x is equal to negative 3. And then the last step, we need to check if these answers are valid. It is an equation with a surd. So at this point, we deliberately squared both hand sides. This can tamper with your answer. So you need to check if the solutions are valid. Okay, so we're simply checking if the left-hand side is equal to the right-hand side, just so that we can see what we're doing. You can just rewrite this equation. Okay, and in place of x, we're just going to substitute this x value so that we can check if the left and the right-hand side balance. Okay, so 2 minus this 8, we can see that that's going to give us a negative 6. So let's substitute. If negative 6 does not come out here, then you know that it's not a solution. So as you can see, that gives you a positive 6. Those are not the same thing. Positive 6 and negative 6 are not the same. So x is not equal to 8. And then if you try this with negative 3, let's see. That's minus 3. And here if you said 2 minus negative 3, you see that that's going to give us 5. And that works out perfectly. Okay, so the left and the right-hand side are equal. So x is actually equal to negative 3, but it's not equal to 8. And that is our answer. Question 1.2, we have been given a simultaneous equation and we need to solve for x and y. So it's best to spot the linear equation. So as you can see, this is the linear equation. The highest exponent on x and y is 1. Okay, so that's going to be our equation 1, and then we'll call that equation 2. So we can use equation 1 to form equation 3. We just need something to substitute into there. Okay, so here we can make x the subject by leaving it on its own. And then the 2y is still on the left-hand side. And we can transpose the 3, so that becomes a minus 3. Okay, so x is equal to 2y minus 3. And this is equation number 3. And now, to finally solve, we're going to substitute equation number 3 into equation number 2. Always the equation that you didn't use yet. Okay, so this is going to be, wherever you see x, we're going to replace it with 2y minus 3. So that is 2x, but you see there's a y after. So it's best to write the y next to the 2, and then we apply that x. So that is now 2y minus 3. And then plus 7 is equal to, and there's an x again. So that's going to be 2y minus 3 all squared. And then plus 4y squared. Okay, so this is, and when we distribute, this is 4y squared. And then minus 6y and plus 7 is equal to, okay, and this is squared, so let's distribute. We're going to say the first term squared, which is 4y squared. This is a 7. And then the last term squared, which is positive 9. Then first term times second term, that gives us a negative 6y. And then we multiply that by 2 to get negative 12y and plus 4y squared. Okay, so we're just putting like terms together. Notice how we have 4y squared and 4y squared. They'll cancel on both hand sides. So you might as well just cancel it out already, because if you took it over, you see it's going to say minus 4y squared. So it's gone. So all we have here is on the right hand side, we have 4y squared, and then we have minus 12y, and we can transpose this negative 6y to become positive 6y, and they add up to negative 6y, and then the constant. So that's a positive 9 here, and transpose the 7. Now that becomes positive 2. Okay, so this is what we have. And we have a common factor of 2. So let's go ahead and just divide both hand sides of this equation by 2. And therefore, I'll just write it on this side. So that divides and becomes 2y squared. That is negative 3y. And plus 1 is equal to 0. Okay, so we have this that we have to factorize. Here is another method we can use. So this is the factor method. Okay, so to factorize this, we can take the first term and the last term and we multiply them together. So that's going to be 2y squared times 1, which is just 2y squared. And now we're going to look for the factors of 2y squared that can give us the middle term, negative 3y. So because it needs to be negative, we can say negative y multiplied by negative 2y. and those together give you positive 2y squared. So this is how we can rewrite this equation. It is 2y squared, and then we're going to fill in these. But we'll rewrite them in a way that they are next to a value with which they share a common factor. So we'll rewrite the negative 2y, so that's minus 2y, and then we have minus y, and plus 1 is equal to 0. Okay, so we're just rewriting negative 3y in the form of minus 2y minus y. And now we're going to use grouping. Okay, so we're going to group the first two terms together, and that's why we rewrite them with the number, the value that they share a common factor. Okay, and then these two are together. So the common factor between the first and second term would be 2y. And then open a bracket, and what are we left with? We're left with y in the first term. And then what are we left with in the second term? You can just say this divided by that common factor. That gives you negative 1. Okay, and then in the second term, what are we left with? Well, this is a negative y and a positive 1. There's actually a negative 1 that's a common factor. So what are we left with? Negative y divided by negative 1 is positive y. And positive 1 divided by negative 1 is negative 1 is equal to 0. Okay, so as you can see, the brackets are exactly the same. So what we're doing is we're really taking out the bracket as a common factor. So we have y minus 1, and then what is left in those two terms. In the first term, when you take out y minus 1, you're left with 2y. And in the second term, you're left with negative 1. And there we go, we've factorized this equation. Okay, so this means that y is either equal to positive 1 or, and of course you're going to say 2y minus 1 equals 0, and you transpose the negative 1. And so divide both hand sides by 2, and we're saying y is equal to 1 over 2. Okay, so we have our two solutions for y, and now we just need to solve for x. So we can call that, since we ended at equation 3, we can call this equation 4. And so the last step would be to substitute equation 4 into the equation where x is a subject. Notice that in equation 3, x was the subject. So substitute equation 4 into equation 3. And so that is x is equal to 2y minus 3. And so we're going to say 2y, but in place of y, we'll substitute. So substitute in 1. And 2 minus 3 is negative 1. So x equals negative 1 here. Or x is equal to 2y again. And here, y is a half and minus 3. Okay, 2 times a half is 1. So 1 minus 3 is negative 2. And those are our answers, okay? So x is equal to negative 1. And at the same time, y is equal to 1. Or x equals negative 2 and y equals a half. And those are our answers. Question 1.3 says, the roots of an equation are x is equal to negative n plus minus square root of n squared minus 4mp over 2m, where m, n, and p are positive real numbers. The numbers m, n, and p in that order, so in the order of m, n, and p, that they form a geometric sequence. Okay, so we'll see how we can apply that. And they want us to prove that x is a non-real number. So x is defined by substituting m, n, and p into the quadratic equation. And we need to ensure that it is a non-real number. So we need to find the values of this root for which it is a non-real number, values of m, n, and p. Well, a quadratic equation's root would be a non-real number if and only if its discriminant is less than 0. And we can see why that is, why we have to specifically look for where the discriminant is less than 0 in this question. Because do you see how we have a square root here? And if the discriminant is the number under the square root, the b squared minus 4ac, right? That is b squared minus 4ac. What happens if this number is less than 0? If this number is negative? Well, then you're going to square root a negative number. When you square root a negative number, you get a non-real value. And so that's the whole point of that. Okay, so in other words, we're really just required to prove, and I'm just going to say it like this. We're required to prove that what is under this radical over here, n squared minus 4mp, so n squared minus 4mp, we're required to prove that this is a value that is less than 0. Okay, so let's just write down our expression. This is what we're trying to focus on. We're trying to find out what exactly this value is going to be. We may not find the numerical value, but we need to really prove that it is less than 0. So what do we know about this? And we can just take into account the other piece of information they gave us, which was that the numbers m, n, and p in that order form a geometric sequence. So m, n, and p form a geometric sequence. Well, what can we do with this geometric sequence? It is geometric, so it has a constant or common ratio. Okay, so that means that when you say the third term divided by the second term, we're going to get p over n. And that should be consistent. It should be equal to the second term divided by the first term, which is n over m. So these should be exactly the same since this is a geometric sequence and these represent the common or constant ratio. Okay, let's see what we can do with this. If this is the equation that we have, we can simplify this further. So we can cross multiply to simplify. N times n gives us n squared is equal to m times p is just mp. So this is what we have. And this is actually a very important piece of information. The expression we're trying to simplify is n squared minus 4mp. And we found out now that n squared is actually equal to mp. So let's update it in our expression. So this means we can even just start writing this over here and that will be fine. So we'll just put this down here and then just push that up. Okay, so let's update that. This means that this expression is actually equal to, in place of n squared, we can just say mp minus 4mp. And these are like terms. So it simply means that mp minus 4mp is equal to negative 3mp. Okay, so what does that say about this expression? This expression simplified to negative 3mp. We know that m and p are positive numbers, positive real numbers. So we took a positive real number times another positive real number, which gives you a positive real number, and then times negative 3. Of course, that's going to be a negative value. Okay, and we can show them that by showing them that m times p, because they're positive real numbers, when they multiply, they're greater than 0. So therefore, negative 3mp, when multiplied, would give us a negative value, a value less than 0. And so there we go. That proves that the discriminant, this, is actually less than 0. So that is n squared minus 4mp is actually less than 0, meaning the discriminant is less than 0. You can't say b squared minus 4ac, it's also fine. And so that would conclude that x is indeed a non-real number. And that's how we would prove that. X is a non-real number because the expression simplifies to a non-real value. The discriminant simplifies to a non-real value. Therefore, this is non-real. And that is our answer. Question 2 says, given the geometric series x and then plus 90 plus 81, we need to calculate the value of x. Okay, so from question 1, this is really just the same idea. We have the first 3 terms. So since it's x plus 90 plus 81, we can use the constant ratio here. Okay, so the constant ratio would find that by saying the next term divided by the previous term. So that's 81 divided by 90. And this should be consistent with this next term divided by that previous term, which is 90 divided by x. And that's the equation that we have. Okay, so you can cross multiply, that's fine. Or you can just think about it as transposing the x. Okay, but if we cross multiply, that's really just 81x is equal to 90 times 90 is, okay, 8,100. And then if we divide both hand sides by 81, x is equal to, and that would be 100. So x is equal to 100, and that is our answer. Question 2.2 says, show that the sum of the first n terms is Sn equals this. So we're really just using the Sn formula, and we're going to actually have to keep in mind, because you notice that the 1 comes before the value that we have here. Okay, so remember that there are two formulas, okay, for Sn. We first have this formula, okay, and we specifically use this formula when r is greater than 1. Now, it doesn't always matter, because what usually happens is the numerator and denominator, if they become negative because you used this formula alone, then they divide. Okay, and the other formula we could use is, it's really the same thing, but the only difference is now we start with 1 and then minus r to the power of n over 1 minus r. And you use this specifically when r is a value less than 1. Now, the reason we have to be careful about this is because we have a 1 here. So clearly they use this one. Okay, now you don't just know that from that. You know that from your ratio, your common ratio. See how when we said the next term divided by the previous term, we have an 81 over 90. That is a proper fraction. The numerator is less than the denominator. So that means this is a value less than 1, and you can verify that on your calculator. So we're going to go with this formula. Okay, so we're finding the sum of n terms. So in place of n, we won't substitute an actual value, leave it as Sn is equal to, and the a value, we found that the first term was 100. Okay, so we're going to say 100 multiplied by 1 minus, and our ratio is 81 over 90. So it's 9 over 10, and then raised to the power of n, and then 1 minus r again. So 1 minus 9 over 10. Now, with this, how we can simplify it to their form, because you see that they don't have a fraction like that. Okay, we can simply just say, because these are being multiplied, this bracket is going to multiply, you can just say the 100 divided by this number over here. 1 minus 9 over 10 is 1 over 10. 100 divided by 1 over 10 is going to give you 1000. Okay, and then that's just going to be 1 minus 9 over 10, as we can see on the calculator, can be represented as 0.9. So that's 0.9 raised to the power of n. And that is our answer, just like they have it as well. Okay, moving on to the next question. Question 2.3 says, hence or otherwise calculate the sum to infinity. So the sum to infinity's formula is a over 1 minus r. So all we need is the value of a and r. So we already know these values. So a is 100 and r is 9 over 10. So that's 1 minus 9 over 10. And we're just going to find out exactly what this is. And the sum to infinity is 1000. And that is our answer. And that is it for question 2. Okay, question 3 says, consider the quadratic number pattern, and we have negative values. And the first question asks us to write down the value of term 4. Okay, so this is only for 1 mark. You do not have to find the general formula for this pattern. So let's rewrite the pattern first. And to get to the fourth term, T4, we can simply just find the differences first. So we'll find the first difference, and we find that by saying the next term minus the previous term. So that's negative 122 minus negative 145, which is really just 122 plus 145. Okay, so what is 145 minus 122? That's just going to be 3, 2, and 0. So 23. Okay, so we have 23 over there. And then same thing, we're going to say negative 101 and then minus negative 122, which will give us a plus 122. So 122 minus 101 is just simply 1 and then 2 and nothing. So 21. So that gives us positive 21. And as you can see, these values are increasing. So yes, they are being added by positive numbers. So that is the first difference that we have. Then, in order to get to term 4, we need the second constant difference. So we find that by saying the next term in the first difference minus the previous term in the first difference as well. 21 minus 23 would give us negative 2. Okay, and so what we know about this is that the second constant difference is constant. So it's going to continue being negative 2. So we're going to also have a negative 2 over here. And so to find the third term in the first difference pattern, it's going to be 21 minus 2 or plus negative 2, which is going to be 19. And so to find the fourth term, we simply just say negative 101 plus 19, and that will give us our answer. So T4 is simply equal to negative 101 plus 19, which is negative 82. So term 4 is simply equal to negative 82. And that is our answer. Question 3.2 says, show that the general term of this number pattern is this. Okay, so we need to find the general term. We have everything we need to find it now. So we're going to look at the first terms in the quadratic, the first difference, and the second difference. And we're going to circle those, okay? We can look at those, and you're going to equate them to the following. So the negative 2 will be equated to 2a. So 2a equals negative 2. And then the 23 gets the 3a plus b. And the negative 145 gets the a plus b plus c. Okay, so let's solve this equation. So we have 2a equals negative 2. So therefore, a would be equal to negative 1. And then 3a plus b. But we already know what a is. It's a negative 1. So 3a plus b is equal to 23. So that's 23. And so b would simply be equal to 23. And this multiplies to give you negative 3. And if you transpose it to the right-hand side, it's going to give you a positive 3. So that would be 26. Okay, and then a plus b plus c. So that's going to be, we already have a, it's negative 1, plus b, which is 26, plus c is equal to the negative 145 over there. So negative 145. And so c is equal to, when you add these together, 26 minus 1 is 25. Negative 145 minus 25 gives us negative 170, okay? Because those give you 160 and then an extra 10. So c equals negative 170. And there we go. The quadratic pattern is in the form of an squared plus bn plus c. So this is indeed negative n squared. Okay, the a is negative, and then plus 26n and minus 170. And that is our answer. Question 3.3 says, between which two terms of the quadratic number pattern, okay, will there be a difference of negative 121? So between which two terms in this pattern will we have a difference of negative 121? So there are two terms in the quadratic number pattern, and when you subtract them to find their differences, it gives you negative 121, and we need to find out between which two terms this would be. Okay, so to find this, you can see that since negative 121 is a difference, it's a difference between two values in the quadratic pattern, then it means that it is part of this pattern over here, which is actually a linear pattern. Do you notice that? It has a constant difference. This will keep being negative 2. So this is a linear pattern. And so if we can find out which term exactly this is in the linear pattern, we'd be able to tell which two terms it lies between. So let's go ahead and find the linear pattern. So it's going to be Tn equals, of course, a plus n minus 1 multiplied by d. And so in place of Tn, because we are looking at a term value and we want to find out what is the term number belonging to this, which term exactly is negative 121 in the first difference, we're going to, in place of Tn, substitute negative 121. And this is equal to, and then we have a, and a in this pattern, the first difference, the first term there is 23. And then we'll say plus n minus 1, that is empty because we're looking for n. And then the difference, we have that difference. It's negative 2. So this is the equation we're going to use. Okay, so looking for n. Let's go. We can transpose the 23. So that's going to be negative 23. And then when it subtracts there, that becomes negative 44. negative 144, right, is equal to, and this is just one term times two terms. So we can say negative 2 times n minus 1. And then we can divide both hand sides by negative 2. And so this is really just, you can rewrite this here. So that's n minus 1 is equal to, when they divide, they give us positive 72. Okay. And then transpose the 1. So n is simply equal to 73. So what this means is that in the first difference, this is actually the 73rd term here. So between which two terms would it lie? If this is term 73, okay, then it means that it lies between term 73 and term 74 in your quadratic pattern. And that's how that would work. Because notice that the terms in the first difference would be one less than the quadratic pattern. In the same way, you can see how the second term in the first difference lies between the second term and the third term in the quadratic pattern. Okay, so there we go. It's term 73 and term 74 in the quadratic pattern. Okay, between the 73rd and 74th term of the quadratic pattern. And that is our answer. Question 3.4 says, what value must be added to each term in the number pattern so that the value of the maximum term in the new number pattern formed will be 1? Okay, so how much must be added to the old pattern so that the new pattern has a maximum of 1? They are specifically referring to a maximum value, okay, or maximum term. Looking at our formula of the quadratic number pattern, notice that the value of a is negative. So what this means is it's going to form a concave down parabola. And this parabola, regardless of where it is, this parabola is going to have a maximum term or maximum value over here. So it has a specific maximum value currently. What they want us to do or to tell them is what should be added to this current one so that the new one has a new maximum of 1. So I've duplicated this graph. So what's going on is we currently have a specific maximum value. We need to find out exactly what that is. And we need to find out how much we need to add or really shift this graph so that its new maximum is at 1. Okay, this is just, I know it doesn't really look like it's drawn to scale, but it's just an example. So that this new is 1. Okay, so the first goal is find out what the current maximum is given the general term that we have here. Okay, so we can find that maximum. It's just find the turning point of the parabola. So you can use negative b over 2a. You can also derive this and that will be fine. I'll use negative b over 2a. So n equals negative b and the b value is 26 over 2a. So a is negative 1. And so that's negative 26 divided by negative 2, which is just going to be positive 13. Okay, so we know now that the maximum occurs at n equals 13. We need to find out what exactly that maximum is. And so to find out what exactly that is, you're going to take that n value of 13 and substitute it into your equation, because that's going to tell you the value at that term 13. So we'll say term 13 equals, and in place of n, substitute 13. And that gives us, so term 13 equals negative 1. Okay, so here is the story. Here's what's going on. We now know that the current maximum happens at negative 1. Again, this is not drawn to scale. Okay, the x-axis would obviously have to be like there. So how much must we add so that the new maximum is at positive 1? From negative 1 to positive 1 is plus 2. So that's what we need to add. Okay, so we can just tell them we need to add 2. Okay, because negative 1 plus 2 would give you that new maximum of positive 1. So therefore, we need to add 2. And that would give us our answer. Okay, so that is it for question 3. Question 4 says, consider the linear pattern. And we have 5, 7, and 9. And we need to determine term 51. So we can use the TN formula for an arithmetic pattern, and that's a plus n minus 1 times D. So we're looking for specifically term 51 is equal to, A stands for the first term. So the first term here is 5 plus 51 minus 1 because n is equal to 51, and then multiply by D. The difference, as we can see, you can see we're just adding 2 every time. So 7 minus 5 is 2, and 9 minus 7 is 2. So that's just 2. And you can just find out what this would be. And that is equal to 105. And that is our answer, 105. Question 4.2 says, calculate the sum of the first 51 terms. Okay, so there are two formulas we can use to do this. We can either use this formula. Okay, it's still the sum of the terms in a linear pattern. Or we could use this formula. Okay, so with this one, we want to find the sum of the first 51 terms, meaning the 51st term is the last term. We already know what the last term is, so let's just go with the easier formula. Let's go ahead and use this. So this is going to be the sum of 51 terms is equal to 51 over 2. And then in place of A, our first term is 5. So we'll say 5 plus the last term is 105. So 105. And that will be our answer, the sum of 51 terms. And that is 2,805. And that is it for this question. Moving on to the next question. Question 4.3 says, write down the expansion of this. Okay, so we have the sum starting from n equals 1 to 5,000 of this series with this formula. Okay, so show only the first 3 terms and the last term of the expansion. Okay, so that's not a problem. We're just simply going to start where they start. They started at n equals 1. So we'll find out what 2 and substitute 1 plus 3 is, and that will give us the first term. And we'll find the second and third, and then the last term. Okay, so the first term is simply just 5. And this is the series, so we're adding, okay, plus the second term in place of n, we substitute 2, and that's just 7, plus the third term, we substitute 3, and that is 9, and this keeps going, and then they want us to give them the last term. The last term ends where n is equal to 5,000, so in place of n, now we substitute 5,000, which is 10,003. And this is our answer. That is what they're asking for. Okay, moving on to the next question. Question 4.4 says, hence or otherwise calculate. Okay, so we have to find this sum. So it's again this one. Okay, and now we're adding that to this sum. Okay, so let's just see. When we have this, right, we still have to find out exactly what the sum is because we didn't really find it. Okay, starting at n equals 1, going all the way to 5,000, right? This expanded to all of this. Okay, so we're going to have to expand the other one as well so that we can just see clearly the value of A and of course D and so on. Okay, so notice that in this one, the first term was 5. Let's just find the things that we need. Since we are working with the sum of series, we would either use that Sn equals n over 2 and then 2a plus n minus 1 times d, or the simple one with n over 2 and then a plus l, okay, which we can just go with that. So our main goal is really just to find that first and that last term, and of course the value of n, the number of terms. Okay, so here I know that a is 5. I also know the difference, but I don't really need that. I know the last term is 10,003. And then the last thing we would need is the number of terms, n. So n, we can use this formula to find n, though in this case it's already obvious. So you can simply say the top number minus the bottom number and then plus 1. So in this case, you see that those will just cancel. So it really is 5,000 terms here. So n is equal to 5,000. So we have everything we need for the first series. And let's look at the second series now. The second series says we're finding the sum where n starts at 1, ending at 4,999, right? And then we have minus 2n minus 1. And let's expand that as well. Let's just find that. So the first term where n is equal to 1, you always start wherever they start. So that's at 1. The first term is negative 3. And then the second term is negative 5. So you can't say plus minus 5, but it's really no use. Just say minus 5, because if you say plus negative 5, it still stays negative 5. And then substitute 3. That gives us negative 7. And this keeps going till the last term. And the last term would be at 4999. So let's go ahead and substitute and see what we get. We get negative 999. And this is what that looks like. Okay, so we can also just find everything we need from here. We need the value of a, which is negative 3. We need the last term, which is negative 9,999. And we also need the value of n. So again here, it's also an obvious case because n starts at 1. So we know that they are indeed 4,999 terms. Okay, so let's go ahead and form this. So we're taking the sum of this series plus the sum of this series. Okay, and this would be equal to, and we're going to find the sum of the series. So, we're going to say Sn is equal to, and then n over 2 times a plus l. Okay, so you don't really have to write the Sn part. You can just substitute. In place of n, the n value here, we had 5,000 terms. 5,000. I noticed I said 500. Okay, so 5,000 terms here divided by 2. And then the first term was 5 and the last term is 10,003. So we'll say 5 plus 10,003. And we are adding this to this one. So again, the sum of 4,999 terms. So we'll say 4,999 over 2 and then first plus last term. The first term here was negative 3. The last term was negative 4 nines. Okay, so minus 3. There's no need to say plus. So it's just minus 9999. Okay, so let's find out what exactly that is going to give us. And the answer to that is simply 20,001. And that is our answer, 20,001. And that is it for question 4. Question 5 says, given f of x is equal to negative 1 over x minus 3 plus 2, we need to write down the equations of the asymptotes of f. Okay, so the general form of a hyperbolic function is y equals a over x minus p plus q. Okay, and the values of p and q are our vertical and horizontal asymptotes. So remember, if a line is vertical, then its equation will start with x is equal because it passes one particular x value on the x-axis. It has multiple y values, okay? Y values all through, but it has one particular x value. So this is x is equal to, and that is the p. As you can see, it's next to the x, so you can remember it like that. And then the q value would be y is equal to, because it passes one particular y value on the y-axis. So that's y is equal to q. Okay, so from that, you can see that x is simply equal to p, which is 3, okay, since that says x minus as well, and y is equal to 2. And those are the equations of our asymptotes. Question 5.2 says, write down the domain of f. Okay, so this has a lot to do with the way the graph looks. The domain is all the possible x values that this graph has. Okay, so with the hyperbola, you will notice that it would have almost every x value. Okay, this is hyperbola where the a value is negative, meaning it wouldn't lie in the first and third quadrant. It would lie in the second and the fourth quadrant. So like that. And looking at where it has x values, you see this is a point over here. It has an x value over here. This is a point over here. It has an x value here. It will have x values for almost every single x value, except for one particular x value. And that is the x value of the asymptote. So the asymptote is a line that the graph will never touch. And that's why it will not have whatever that x value is. we know that this vertical line, the vertical asymptote, is x equals 3. So it will have every other x value except for the x value of 3. And this is how we write this down. So we can say that x is an element of all real numbers, but x will just not be equal to 3. And that is our answer. If you want to write these as intervals, we could write it like this. Because we're speaking about all real numbers, we're starting from negative infinity. So x is an element of negative infinity all the way to not necessarily just positive infinity. We need to stop at 3 and ensure that 3 is not an included value. So we're saying that it's going from negative infinity to values less than 3. Okay, and then it continues. So we'll say union, and we're saying it's continuing from after 3, not exactly at 3, and that's why we're using the round bracket again, going all the way to infinity. Okay, so going from negative infinity to less than 3, and then greater than 3, and then all the way to positive infinity. Okay, so you can write it like this or like that. Question 5.3 says, determine the coordinates of the x-intercept. Okay, so the x-intercept, we will find this where y is equal to 0 because it lies on the x-axis. It intersects the x-axis. So we take the equation of our hyperbola and we make y equal to 0. Y is the f of x part. So we say 0 is equal to, and that was negative 1 over x minus 3 and plus 2. And we just need to solve for this equation. Okay, you see, this is a fraction, and because that number in the numerator is negative, it really just means that the fraction is negative. So you can transpose it, and then it becomes positive. So it's now 1 over x minus 3 is equal to 2. And now we need to solve for x. So we can cross multiply. So it's the 2 that is multiplying with the x minus 3. It's one term, so it needs to multiply to both x and 3. So that gives you 2x minus 6 is equal to, and here the 1 multiplies with the natural denominator of 1 here. Okay, so this is 2x is equal to 1, and that becomes a plus 6, which is 7. And if you divide both hand sides by 2, x is equal to 7 over 2. So to answer their question, the coordinates of the x-intercept would be 7 over 2 and 0, because the y value is 0. And that is our answer. Question 5.4 says, write down the coordinates of the y-intercept. The y-intercept, we will find that where x is equal to 0. So take our function again, but this time we'll make x equal to 0. So in place of x, we say 0, and then that's 0. Okay, so f of 0 is simply equal to, that's going to be negative 1 divided by negative 3, which is just 1 over 3, plus 2. And so that gives us 7 over 3. So there we go. So the coordinates, okay, the x value is 0, while the y value is 7 over 3. And those are the coordinates of the y-intercept. Moving on to the next question. Question 5.5 says, draw the graph of f, clearly show all asymptotes and intercepts with the axes. Okay, which we have. So we can put down our Cartesian plane. And then next, we can just go ahead and put down the asymptotes. It's best to start with the asymptotes so you know the limits of your graph and where they should not go beyond. Okay, so our asymptotes were x equals 3 and y equals 2. So the vertical asymptote is x equals 3. So we can put that, and it's going to be a dotted line. So there we go. And that is x equals 3. And then the horizontal asymptote, and that is y equals 2. So that is going to be a horizontal line, and it's going to be dotted as well, and it's y equals 2. Okay, now the value of a is negative, so we know that it's going to lie in the second and the fourth quadrant. So that is 7 over 2 and 0, which is about 3.5. So 3.5, that is the x-intercept. So if that's the x-intercept, if this is 3, 3.5 is about here. Okay, so that's over here, as long as it makes sense with where these other points are, okay, the asymptotes. So that is going to be 7 over 2. and then the y-intercept of 7 over 3. Okay, let's just see what 7 over 3 really is. Roughly, where is it? 7 over 3 is about 2.3 recurring. Okay, so 2.3 recurring, the y-axis, this is 2, and then so it's just a little higher. Okay, so let's just say it's over here, and then we'll say that is 7 over 3. So we can see the x and y intercept. And we know that the graphs lie in the second and the fourth quadrant. So they're going to look like this. It's going to go like this and run down and then just shoot out like that, moving closer and closer to the asymptote, but never touching it. Okay, so the first wing looks something like that. I just adjusted that point. And then the second one, it has to still pass the x-intercept. So it's going to shoot from the bottom, shooting up, and then move closer and closer to the asymptote, but never touching it. Okay, so something like that, and just moves closer, and this one is moving closer to this one, but it will never touch it. Okay, so that is what our graphs look like. We have indicated the asymptotes and the intercepts, okay, and that is the graph of f, and that is our graph. So that is it for question 5. Question 6 says the graph of f of x equals log x with base 4 is drawn below, and we have b, which is k and 2, and it's a point on f. 6.1, we have to calculate the value of k. Okay, so just look at it like this. This is the graph of f. K is the x value, 2 is the y value. Substitute that point into this graph, and that will give you the value of k. So we're simply just saying f of x is equal to, we have log x base 4. In place of f of x, we're going to substitute the y value of 2, because that's the y, is equal to, and in place of x, we're going to substitute k. Okay, so looking at it like this, how do we solve for k? You can put it back in exponential form, and this will help to solve for k. The base is 4. So we are saying 4 raised to the power of, now when rewriting this as a log function, the exponent is the subject. So that's what we have over there. So it's raised to the power of 2, and that is equal to the answer k. That's what k is equal to. So k is simply equal to 4 to the power of 2, which is 16. And that is our answer. Okay, moving on to the next question. Question 6.2 says, determine the values of x for which f of x is greater than or equal to -1, but less than or equal to 2. Okay, so we need to find out where f of x, which is the y values of this graph, would be greater than or equal to -1. So let's say -1 is maybe over here. Okay, we have a point with a y value of -1, but less than or equal to 2. So here is our point with a y value of 2. So they're really just telling us to find the values of x for which this section of this graph exists. So for us to do that, we need to first find out, because we already know when y is equal to 2, the x value, that k is equal to 16. Now we just need to find out when y is equal to -1, what is that x value? And then we'll be able to tell them for which values of x this section of this graph exists. It will just be between whatever number this is and 16. So let's find out what the x value is when y is equal to -1. So we're still using this log function, but in place of y, we're going to substitute -1 to find out where this is. So this is -1 is equal to, and this is log, and then we're going to leave our base as 4. And now we can rewrite it again in exponential form, because you see that in order to solve for x, we need it back in exponential form. So we're saying that the base of 4 raised to the exponent, which is your answer over there of -1, that is going to give us x. So x is equal to 4 to the power of -1 is 1 over 4. So that's what that number is. This number over here is simply 1 over 4. So where is f of x, the y values of this graph, greater than or equal to -1, but less than or equal to 2, it would be all through here. And if we line these up to the x-axis, you see that these are values that are greater than 1/4, but less than 16. So we can say, but equal to as well. Okay, so x is greater than or equal to 1/4, because at 1/4, the y value is -1, and they want it to also be equal to. The y value can also be equal to this, but less than or equal to 16, and that's what our answer will look like. Okay, you can of course write these in intervals. Okay, so that will be x is an element of, and we're just going from 1/4 to 16. So 1/4 to 16, but we'll use square brackets since these are two included x values. And that is it for that question. Moving on to the next question. Question 6.3 says, write down the equation of the inverse of f in the form y is equal to. Okay, so the inverse of f. So our equation was this. We already had it. And you can just write this in terms of y already. And then to find the inverse, we're just going to swap x and y. So this is going to be y equals, to find the inverse, we switch x and y. So x is equal to log of y base 4. And now we just need to make y the subject. Okay, to do that, we're simply looking at, always focus on the base first. If you get the base, then it usually works out fine. Okay, so we're going to say 4 raised to the power of, now remember what goes in the exponent is what your log function is equal to, because it makes the exponent the subject. So that is to the power of x, and then this would be our answer over here. Y is equal to, that's what the exponential expression is equal to. So y is equal to 4 to the power of x, and they want us to leave it in the form of y is equal to, so that is our answer. Moving on to the next question. Question 6.4 says, for which values of x will x multiplied by the y values of the inverse be less than 0? So in order to be able to find this, we need to understand what that inverse looks like. So the original is a log graph, and so the inverse will be an exponential function. And here's how we can understand it. You have to look at what this graph is doing. Because the inverse and the original, they switch x and y values. That's what the graph is going to do. So whatever it is doing on the y-axis, the inverse will do on the x-axis. Notice what it's doing. On the y-axis, towards the negative part of the y-axis, the graph starts to increase and then it shoots up like that. Now, the inverse is going to do the exact same thing, but it's going to do this on the x-axis. So with the original graph, on the negative part of the y-axis, notice that the graph was closest to that y-axis. It's going to do the exact same thing on the x-axis. It's on the negative part of the y-axis, so this will start on the negative part of the x-axis over here. So it's going to be closest to the x-axis and then gradually increase from there. And then it will look like that. So we get an idea of what that looks like. Another way to see this is, you see that we had a point 16 and 2. The x and y values will just switch. So that's going to be 2 and 16. Okay, so if you went 2 units to the right and 16 units up, you see that it will be high up there. And so it would still do that. Okay, so that would be the inverse. Now, the question specifically is, we're going to take the values of x, right? And we're multiplying it with the y values of the inverse. And they need to give us a value less than 0. Here are the situations where this could happen. It's either that the x values, and you're going to focus on the x-axis for this, your x values were positive and they multiplied by negative y values of the inverse to give you a value less than 0, to give you a negative value. Or the second scenario where this could happen would be when the x values are negative and we're multiplying by positive y values of the inverse. Okay, and then that would be a negative result as well. Okay, so we're just trying to formulate ways to get a negative number. Positive times negative is negative, and a negative times a positive is negative. So let's see where this happens in our graph, on our graphs. So where do we have positive x values and at the same time we have negative y values for that inverse? So positive x values, since they're specifically x values, you can look at the x-axis. Where do we have positive x values? We have positive x values over here. Okay, so for these same x values, the y values of the inverse need to be negative. Do you see that for these same x values, okay, if you line that up, the y values of the inverse are all positive. These have positive y values. If you match them to the y-axis, all of them have positive y values. So it does not happen with this scenario. This case does not happen. Okay, we can look at the next case. That would be where your x values are negative and then the y values of the inverse are positive. Let's see if this happens. So we need negative x values. The negative x values happen over here. And for the same x values, the y values of the inverse need to be positive. Okay, so for those same x values, look at what the y values of these are. If you line them to the y-axis, they're all positive. Okay, so we're just telling them the values of x for which this part of this graph exists. And you can see that it starts off here. There's nothing here. It won't work anything here, but it will start here where the x value is equal to 0, and then it moves to the left-hand side. So these are values where x is less than, cannot say equal to because they didn't really ask for that. They just said where it is less than 0, not equal to 0. So x is less than 0. These are all these values moving towards this side. That would be the values of x for which this selected section of the graph that they asked us to find would exist. Okay, so our answer is simply x is less than 0. This can be written in interval notation as well, which is x is an element of, because its value is less than 0, you're looking at it as it's from 0 and then value is less than 0. So it starts off at negative infinity and then ends off less than 0. So that is going to be from negative infinity all the way to 0, but not including 0. Okay, and that is it for question 6. Question 7 says, the graph of f of x is equal to x plus 4 times x minus 6 is drawn below. The parabola cuts the x-axis at B and D and the y-axis at G. C is the turning point of F, and then line AE has an angle of inclination of theta and cuts the x-axis and y-axis at A and E respectively. T is a point on F between B and G. And the first question is to determine the coordinates of B and D. Okay, so we can see that B and D are simply our x-intercepts. So this is where y in our parabola is equal to 0. You see how that's going to work out. We're just going to say 0 equals, and that was x plus 4 and x minus 6, right? X minus 6. And then we just solve for x. So this is where x is equal to negative 4 or x is equal to 6. They've already factorized it for you. So just point out which is B and which is D. B is more to the left, so that's the negative 4. And D, that is the positive 6. So we'll just tell them that B is negative 4 and 0 as an x-intercept. And D is 6 and 0. And those are our answers. Question 7.2 says, calculate the coordinates of C. Okay, we know that C is the turning point. Okay, so to find C, we need to find the x value of the turning point. But here's the thing. Yes, we have the entire equation. Instead of going through the whole process of foiling that out and then finding that x value of the turning point, you can actually use this method. We know that the x value of the turning point, that is the middle. It's the midpoint of your x-intercept. Okay, so we can just use that. So we're going to say, to find the x value, we'll say -4 plus 6 over 2. That will find the midpoint of that x value. So that's 6 minus 4, which is 2. 2 divided by 2 is 1. So the x value is 1. And so to find the corresponding y value, we can take 1 and substitute it into our parabola so it can find that y value. Okay, so we're saying f of x is equal to, and then let's just substitute, and we'll say f of 1 so we can find that y value where x is equal to 1. And that's going to be 5 times -5, which is -25. So f of 1 is simply equal to -25. And so the coordinates of C are 1 and -25. And that is our answer. Okay, moving on to the next question. Question 7.3 says write down the range of f. So the range refers to all the possible y values that this graph can have, all the y values of this graph. So we know that this is a concave up parabola. So it's not going to have any graph down here below that turning point. The lowest y value it has would be the y value of the turning point, which we now know is -25. So the y values start at -25, and then there are values that are greater than -25. Okay? As you can see, these points on the graph, they only have values that are greater than -25 or equal to -25, because at the turning point, that is an actual point. So here is our answer. The y values, all the y values of this graph would exist where y is greater than or equal to -25. And of course, you can write this in interval notation, which is where y is an element of. So you can look at this on the number line. And so that is where we have the y value being -25. And it's greater than or equal to. So it's equal to at -25, and then values that are greater than -25. Okay, so the lower value is -25, and the higher value is heading towards, you see, positive infinity. So infinity, and then we'll use a square bracket for -25 since it's an included value, and then a round bracket for infinity because this is not a fixed value. Okay, and that is our answer. You can write it like this or like that. It's perfectly fine. Question 7.4 says, given that theta is equal to 14.04 degrees and the tangent to f at t is perpendicular to AE. Okay, so they've told us what the angle of inclination is, 14.04 degrees. And they're saying that the tangent, okay, to this curve at t, so that line that is going to touch the curve once, at that point t, that is perpendicular to this line AE. Okay, so we know what to do with their gradients. So if that is the case, they want us to calculate the gradient of AE corrected to decimal places. Okay, so they already gave us the angle of inclination of AE. And what we can do with that is find the gradient. See, the formula to find the angle of inclination is tan theta is equal to the gradient. So this will help us find the gradient. We already know the angle of inclination. So we'll say tan 14.04 degrees is equal to the gradient. So I can just say gradient equals. And let's find this. Let's find out what tan 14.04 is. So that's simply tan 14.04. And we get, okay, it's really 0.25 because it's just going to round off like that. So we know what the gradient of AE is. This is the gradient of AE. Okay, so that is the gradient of AE that they're referring to, and this is for 1 mark. So there we go. The gradient of AE is 0.25. You can also say 1/4 because that is 0.25 as well. And that is our answer. And then finally, question 7.4.2 asks us to calculate the coordinates of T. So what are the coordinates of T, that point, okay, where this graph is a tangent? Well, what is the only thing we know about this point? We know that there is a tangent to F at this point, and that tangent is perpendicular to AE. So we can find its gradient. And then because we have the gradient of this tangent, we can find out where the gradients are going to be the same on the parabola and at that point. So let's go ahead and find the gradient of this tangent first, since it's perpendicular to AE. So AE's gradient is 1 over 4. Therefore, the tangent, the gradient of the tangent would be equal to, you simply just switch the numerator and denominator and then multiply this value by -1. So that's going to give you -4. It holds the theory that the gradient of two perpendicular lines multiplied give you -1. So this is the gradient of the tangent that we just found. And now we need to find the coordinates of t. So at t, again, the parabola and the tangent share the exact same gradient. So we can find out where exactly is the gradient also equal to -4 on the parabola. So yeah, now we'll need this part and we'll need to distribute. So f of x is equal to, and let's rewrite what f of x is first. And distributing, this is f of x is equal to, and that is x squared. And then if you distribute, that's going to be -6 plus 4, which gives us -2. So -2x. And then lastly, minus 24. Okay, so this is what we have. And we're trying to find out where on this parabola do we have a gradient of -4, because that would point out where exactly t is, since the gradient of the tangent where t is -4. So to find the gradient of the parabola, we simply derive it, find the first derivative, that is the gradient. So gradient is equal to coefficient times exponent, that's 2x, exponent -1 is 1, and you don't have to rewrite that. Same thing over here, coefficient times exponent is -2, but the x will fall away because exponent -1 gives you 0, and anything to the power of 0 is 1, and that just multiplies to the -2. So this is the general gradient of the parabola. We specifically want to find out where the gradient is equal to -4. So we're saying, therefore, the gradients need to be the same. We're trying to equate them so that we can find out at which x value this happens. So this is 2x is equal to, transpose the -2, that's 2 minus 4, which is -2. So therefore, x is equal to, if you divide both hand sides by 2, x is equal to -1. So it's at this x value of -1. Great. Now we need the full coordinates of t. So if we know the x value here is -1, then to find the y value, simply substitute that x value into the equation of the parabola, since we have the full equation there, and then we'll find the y value. So this is f of, or putting it in the original equation, so f of -1 equals, and let's just substitute that there. Okay, so f of -1, we have 1 plus 2, because that's going to become positive. That's 3 minus 24, which is -21. So it means that the coordinates of t are -1 and -21. And that is our answer. Question 7.5 says a straight line G, which is parallel to AE, that it cuts F at K being -3 and -9 and R. And we need to calculate the x coordinate of R. Okay, so remember how we had a parabola, right? And on this parabola, we had that point AE. Well, A was really just, we just have to look at the way that looks. It's not necessary to take this whole thing really. AE is over here, right? This line is parallel to AE. So A to E like that. When we look at it like this, if we have AE going like that, okay, so something like that, and A was on the x-axis while E was on the y-axis. So this line is parallel to AE. Okay, so it's parallel to AE. and then it passes. What they say is that it cuts the parabola f at k, which is -3 and -9. So we can look at it like this, -3 and -9, and at r. And they just want us to find the x coordinate of r. So in other words, this is the point of intersection between this new line and the parabola. So if we find the equation of this line, we can simply equate it with the equation of the parabola to find the points of intersection. And we'll just choose r's point of intersection, specifically the x value. Okay, so how do we do this? We need to find the equation of this line. Well, it's parallel to AE. So what was the gradient of AE? The gradient of AE was 0.25 or 1/4. If lines are parallel, they have the same gradient because they have the same slope. They're slanted in the same way. Okay, just move that aside. So it means that the gradient of this line G that they're referring to is also 1/4. But this graph G, right? Do you see that it actually has a point on it? The point K is a point on it, okay? So it's -3 and -9, so we can substitute that into the graph. So to find the equation of G, we'll say y minus y1 is equal to the gradient times x minus x1. And so that is y minus, and we're substituting k, -3 and -9, since it's the only point we have on this graph G right now. So minus -9, which just becomes a +9, is equal to the gradient of 1/4 times x minus -3, which becomes a +3. And so this is simply equal to, you can say 1/4x, because they distribute, and then that becomes +3/4. And the 9 gets transposed, and that is -9. Okay, so y is equal to this, and simplify, it's just 1/4x. If you put this over 4, it's just going to be times 4 over there. 9 times 4 is 36. So 3 minus 36 is -33. So that is -33/4. Okay, so this is the equation of G. Let's call it G of x. That's fine, right? So now that we have G, we're just trying to find the points of intersection between the parabola and the graph of G, but we're specifically going to focus on this one, okay? And we just want the x value. So this is where the parabola's equation is equal to the graph of G's equation. Remember that the parabola's equation looks like this, of course, with the x's instead. So here it is over here, and we're just going to equate them. So f of x is equal to g of x. And we know that f of x equation looks like this. So we're just saying that this is f of x, and it's equal to g of x, which is this. Okay, so it's 1/4x minus 33/4. And now we just have to solve for x. So x squared minus 2x, and then transpose the 1/4x minus 1/4x minus 24 transpose, that's positive 33/4, is equal to 0. So we have x squared, and that together will be negative because we're going to just multiply. So that's going to be 8 plus 1, which is 9. So -9/4x, and then okay, so if you multiply that by 4, 24 times 4 is -96, so plus 33. So they're both over 4 now. Okay, so that's going to be -63. So really this just looks like this. X squared minus 9/4x, and then minus 63/4 is equal to 0. To solve for x, we can't just get rid of this denominator of 4, so we can factorize. Okay, so that's if it can be factorized. We'll see. It may be decimals, but we'll see. Okay, multiply both hand sides by 4 to get that 4 out of the denominator. And now we'll have 4x squared, and then the 4's would cancel with the denominators of 4. So that's -9x, and minus 63 is equal to 0. Okay, we have to factorize this. So we can look at our factors like this. We're saying 4x multiplied by x gives us 4x squared, and then factors of 63 that can help with these to give us negative 9 in the middle. So 63, let's try 7 divided by 7 gives us 9. Let's just see if 9 and 7 work. So 7 and 9. Okay, and then we'll have to see if this works. Okay, but that already gives 36, so it's not going to actually help to give that negative 9. What you can do on your calculator is you can factorize it here using the quadratic equation. Just don't show that, just in case you need to get marks for factors. Okay, so negative b plus minus, so negative, and the b value is negative 9, so we'll say negative 9. And then plus, starting with plus, the square root of b squared, which is negative 9 all squared, minus 4ac, and the a value is 4, and c is negative 63, and then over 2a, so over 2 times 4, which is, okay, that's an interesting one. It's already telling you that the x value is equal to 21 over 4. What this means about the factor is the factor looked like this. It started off as, it's kind of like transposing that 21 over 4. It started off as x minus 21 over 4. And then this 4 was actually the coefficient of x because it was 4x minus 21. If you took that and you made it equal to 0, again, you see 4x is equal to 21, divide both hand sides by 4, and you end up with 21 over 4. So there's our factor. And then the other factor would be change that to a minus, and you can see it's negative 3. So if x is equal to negative 3, our other solution is negative 3, then the factor would be x plus 3. Because you must have said x plus 3 is equal to 0 to get x equals negative 3. Okay, so there we go. So we have those factorized and we've solved for x. Now we need to pick which one belongs to R. Remember that it cut the graph of f at 2 places, here and here. We see that one x value is negative 3. That is clearly k. And then the other x value is what will take as R. So the x value of the point R, that is the 21 over 4. And that is our answer. Okay, so we're going to reject this one because we already have that. So that is our answer, and that is it for this question, for question 7. Question 8.1 says, a farmer buys a tractor for 980,000 Rand. The value of the tractor depreciates annually at a rate of 9.2% per annum on reducing balance method. Calculate the book value of the tractor after 7 years. Okay, so they're using a lot of key concepts here. So we know it is depreciation. We know that it is on reducing balance method. Reducing balance is compound depreciation. We can call this compound decay. Okay, and they want us to calculate the book value. When you're looking for the book value, this is the end amount that you will have. Okay, so this is the A value, the accumulated, not really accumulated in this case because of course it's going to depreciate. So not accumulated in the sense that it's appreciating. Okay, so the formula for compound interest decay is A is equal to P times 1 minus I raised to the power of N. And we know we're looking for the book value, so we're looking for A. And they tell us that the farmer bought the tractor for 980,000 Rand. That is the starting amount. And so at the end, the amount should be smaller because it's depreciating. And so it is 1 minus, and this is 9.2%, okay, per annum. It's not compounded in any way. So this is 0.092. And then raised to the power of how many years does this depreciate for? 7 years. Okay, so let's go ahead and just find A. And this is our answer. So the tractor will now cost 498,685 point, and it's going to round up to 2, so 0.82 cents. Okay, and that is our answer for 8.1. Moving on to the next question. Question 8.2 says, how many years will it take for an amount of 75,000 Rand to accrue to 116,253.50 cents in an account earning an interest of 6.8% per annum compounded quarterly? Okay, so this is clearly compound interest growth. So the amount starts at 75,000. So the formula would be A equals P times 1 plus I raised to the power of n. Money is being invested and then it grows to this amount. So the amount we start off with is 116,253.50 cents is equal to, and we have 75,000 rand. 1 plus the interest is 0.068 and it's compounded quarterly, so we'll say over 4, okay, so that interest is divided by 4 and it will earn interest every quarter. Now what it is raised to the power of, yes, we have n, but think about it like this. Whenever they give us the value of n, say n was like 5 years, because you know that this is compounded quarterly, it needs to earn interest every quarter. So we would say the 5 years multiplied by 4 so that we can ensure that it earns this interest that has been split in 4 parts. It's going to earn that interest every quarter. And it will earn the interest for the full quarters that is in that amount of years. So because of that, so that we can keep track of this, because they want to know how many years at the end of the day, not how many quarters. So we're going to keep track of it by saying n multiplied by 4. So 4n would represent the total quarters we will have. And then finally, when we divide by 4, it's going to represent the total years. So now you see that we just have to solve for the exponent. So what should leave so that we can get closer to the exponent? We should probably get rid of this 75,000. So we can divide both hand sides by 75,000. And then I'll keep writing this like that. And let's just not change this. So it is equal to, and now these cancel and you're left with what's inside the bracket. But what's inside the bracket is really a fraction. So let's just add them together and find out what they give us. Okay, so you can take it in decimal form or as a fraction. It looks simpler in decimal form. So we can say that this in the bracket is 1.017 raised to the power of 4n. And we're still trying to get closer to the exponent. So at this point, we can actually make the exponent the subject. And to do that, we're going to use log. So we're simply going to make the exponent the subject by saying 4n is equal to, and we'll say log, and our base is the number that is carrying the exponent. So that is 1.017. And then the answer that we'll put here is that 116 and that. Okay, so let's put this on our calculator and find out what 4n, which represents the total quarters that we'll have. Let's find out what that gives us first, and then we'll look into the years. Okay, so 4n is equal to, and this is 25 point, and you see that we just have 9s all the way. So this is really going to round up to 26. But we'll take the answer like this, and this is just the quarters first. Then if you divide both hand sides by 4, we can see the years. So n is simply equal to, and let's divide that by 4. You can take all of this as the answer and just say divided by 4. So then that gives us 6.49, and you can see the 9 keeps going. So it's going to round up to a 5. Since that 9 adds a 1 and then that adds a 1. So n is equal to 6.5. Okay, so 6.5 years. And that would be, so 6.5 years. That's how long it would take for this investment to reach this amount if it was compounded quarterly at that stated interest. And that is our answer. Question 8.3 says, Tabo wanted to save 450,000 Rand as a deposit to buy a house, okay, on the 30th of June 2018. He deposited a fixed amount, they're not saying how much, of money at the end of every month. Okay, so this is a consistent depositing of money going on into an account earning interest of 8.35% per annum compounded monthly. His first deposit was made on the 31st of July 2013 and his 60th deposit was made on the 30th of June 2018. Calculate the amount he deposited monthly. Okay, so you can see that this is a situation where someone is saving the same amount of money every end of the month. Okay, so when this happens, this is future value. Okay, it's not like one amount goes in and then it grows. This is somebody periodically saving the same amount. So we're going to use the future value formula here, which looks like this. And we can see from the information that the future value itself is 450,000 Rand because he wants to buy a house costing this amount. So we want to know what he needs to keep putting in order to achieve that. So that is the future value, 450,000 Rand is equal to X is missing. We need to find out how much he deposits every month. And then we have 1 plus, and the interest is 8.35. So that is 0.0835 over 12 because it's compounded monthly. And then raised to the power of how many deposits did he make? That N value stands for the total deposits. He made 60. So that's going to be 60. And then minus 1 all over the interest, which is 0.0835 over 12. Okay, so this is a situation where we're looking for X and everything else is filled in. So all of these, when we calculate them, they're simply just going to give us a number. So we can take that number to get X on its own. We can take that number and simply divide it on both hand sides to get rid of it. So we're basically saying 450 divided by all of this. Okay, 450,000 specifically. Okay, so it's going to look like this, and we just have to put this on the calculator. Okay, and now we see the amount that he needs to save every month. This is going to be 6,068.69 cents, and that is our answer. Moving on to the next question. Question 8.3.2 says, Tabo bought a house costing 1,500,000 Rand and used his savings as the deposit. Okay, so that is that 450,000 Rand that he ended up saving. He obtained a home loan for the balance of the purchase price at an interest of 12% per annum compounded monthly. Okay, so he's obtaining a loan on the balance. So minus the 450,000 Rand. So he's going to take out a loan on the remainder after paying that deposit. And this loan goes for 25 years. He made his first monthly installment of 11,058.85 cents towards the loan on the 31st of July 2018. And the first question is, what will the balance outstanding on the loan be on the 30th of June 2039, 21 years after the loan was granted? Okay, so it's great that they told us this so we don't have to overthink it. So here is what is going on. We have on the 31st of July 2018, this is where he pays his first installment of 11,000, right? Now, this loan is going to go on for 25 years. So that's 18 plus 25, which is 43. Okay, so this would be the last payment on his loan would be in June. Okay, so July has 31 days, June has 30. It would be the 30th of June 2043. Okay, it has to be June because the thing is, with these months, when you're calculating 1 year, for example, from January, you say January to December. That's exactly 12 months. You don't say January to January because then you'll be adding an extra month. That's the same idea here. If we started with July, you end with a month earlier than July, and that would make it a full year or full years in those cycles. Okay, so not July to July the next year, July to June the next year. Okay, and really all that is going on here is 21 years later, and they tell us that that is on the 30th of June. You see why they also say June. Okay, 2039. That we need to find out what is the balance outstanding on the loan. Since this question is based on a loan, we are going to use the present value formula because we're trying to see the balance outstanding on the loan. Okay, so the present value formula looks like this. And we're specifically trying to find out how much he owed after 21 years. Now, you see this PV, the present value, that's what that tells you. It will tell you how much you owe at different time intervals. So right now that is empty because we're trying to find out how much he owes after 21 years. So this is equal to X is the monthly installment that is going to keep paying to pay off this loan, which is 11,058.85 cents. That is how much is going to pay every month. And then we have 1 minus 1 plus, and the interest on this account is 12% per annum compounded monthly. So that is 0.12 over 12 raised to the power of, now this part is important. You see with a negative n. In present value, what this stands for is the amount of payments that still need to be made, or the amount of years you still have to go, years or months, depending on the compounding. Now, in this case, we're trying to find out what the balance is after 21 years. After 21 years, if this is 21 years, okay, then after 21 years, how many more years does he have left to pay off this loan? He would have exactly 4 years to go because this loan is for a total of 25 years. So here, we're going to specifically put -4. But of course, this is compounded monthly. So you need to ensure that you multiply by 12 so that it actually tells you what will be owed after that total amount of months that you have left. Okay, and then we'll say all over the interest, which is 0.12 over 12. Okay, so let's go ahead and put this on the calculator and find out how much will be owed at this time. And this is equal to 419,948.32, okay, 0.32 cents. So that is how much will be owed after 21 years. And that is our answer. Moving on to the next question. Okay, the next question, which should be B, it says calculate the interest Tabo will have paid over the first 21 years of the loan. Okay, so we have to think about this. You see, with the timeline, this would really help us a lot. The amounts that a person pays and the amounts they owe are not the same because of the interest that is added on the loans. So we're going to have to see, to find the interest, you need to find out how much was paid. And then if you take away how much was actually owed, then we'd be able to find the interest. Okay, so it's owed because at different times, for example, 21 years later, if you went to the bank and tried to find out how much do I owe right now, this is how much he would owe. Of course, if you let those 4 years pass, then, it's going to accumulate as he's paying off that loan. So he may owe this after 21 years, but he's not actually going to pay that. So we're looking at 21 years. To find out how much he paid, this is quite simple because we know how much he's paying every month. He pays 11,058.85 cents every month, right? And he's paying this for, since we're looking at this within the range of 21 years, we're going to say multiplied by 21. And of course, he's paying this every month, not just 21 years as in every year. So we will say times 12 as well. And so that would tell us how much he paid in those 21 years. So how much he would have paid would be 2,786,830 and that would just be 20 cents. Okay, so this is how much he would pay in those 21 years. But the amount that he actually owes is going to come from this. This is how we can find that. You see that when we try to find out how much he's going to owe after 21 years, we found out that this amount was this. So you see that the amount that he owed after 21 years, the amount that was going to be outstanding for this remaining 4 years would have been this. What we're trying to find out is how much he would have owed here, okay? So if we know that the amount owed after 21 years was 419,000 and that, then to find out the amount owed here, just take the entire value of this loan, minus the 419,000. And that's how we'll find out how much he was supposed to have owed within 21 years. Okay, so we need the entire loan. And to find out what that was, remember that he bought this house costing 1,500,000, but he paid a deposit, okay? This 450,000 Rand was a deposit that he paid. And they tell us this over here. They tell us that he obtained a home loan for the balance, okay, of the purchase price, for the balance. So he doesn't just take out the loan on this amount. So to find out that balance, and so this is an extra thing that we need to calculate. We need to find out what the balance on the loan was. And that would be 1,500,000 Rand and then minus 450,000 Rand. And that would be that balance, which is 1,050,000 Rand. Okay, that's what we have there. So now to find out how much he would have owed in that 21 years, again, we're going to say the entire value of the loan minus the amounts that he would have owed in this last 4 years after 21 years has passed. Okay, so that would be the 1,050,000 Rand minus this 419,000, because that's what he would have owed the bank after 21 years has passed, meaning within that 4 years that he had left to pay. Okay, and that amount is 630,051.68 cents. That is how much that is going to have owed. And now we can get to the whole point of this. We need to calculate the interest. The interest will be found by saying the total amount paid, okay, within that period, minus the total amount he would have owed within that period. And so that is going to be the interest. Finally, is going to be found by saying the amount paid, which is 2,786,830.20 cents, minus the amount that he owed, which is 630,051 Rand 68 cents. And let's go ahead and find that interest. And the total interest that he would have paid would be 2,156,778.52 cents, way above the amount that he actually owes for the loan for the entire 25 years. This is because with loans, interest is added. So most of the time when you reach about maybe even half the time frame that you're supposed to pay the loan in, you've already paid the bank back the loan. You're really just paid interest. Okay, so that is the interest after 21 years. And that is it for the financial maths section. Question 9.1 says, determine f prime of x from first principles if it is given that f of x is equal to 2x squared minus 3x. Okay, so to determine this from first principles, we still have to find the f of x plus h. So let's go ahead and find that. Wherever we see x, we replace it with x plus h. So this is 2 times x plus h all squared, and then minus 3 times x plus h. And now we simplify. So this is 2, and when this gets squared, you can write it twice and then FOIL it out, but that takes a while. So what we can do is simply square the first term, which is x squared, square the last term, positive h squared, and then first times second term is xh, and then you just multiply that by 2. So that's positive 2xh. And then we can distribute that. So that's minus 3x and then minus 3h. And when we distribute the 2, we have 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And here's the formula to find the derivative using first principles. Okay, so we're going to substitute. So we're saying that f prime of x is equal to the limit as h approaches 0. And it is all of this. Okay, and this is going to be minus f of x. F of x is 2x squared minus 3x. So you see that that's going to need brackets. 2x squared minus 3x. And this goes all over h. Okay, so this is equal to the limit as h approaches 0, and we'll still have the f of x plus h part. And this is equal to minus 2x squared because they distribute, and plus 3x all over h. Now, you know that all that will cancel in the numerator. It's just whatever you were subtracting by. So this cancels with the positive of that, and that cancels with the negative of that. So this is equal to the limit as h approaches 0, and we have 4xh plus 2h squared minus 3h all over h. So this is equal to, and now we can finally fix the issue that we would have had with this. H is on the denominator, so we're going to take h out as a common factor so it can cancel with that, and we don't end up with an undefined value. So when we take h out of the first term in the numerator, we get 4x, and then out of the second term, we get 2h, and the third term will be left with minus 3 all over h, and now it cancels. So at this point, you can substitute. It's perfectly fine. So we'll say 4x plus 2. In place of h, we say 0 minus 3. So f prime of x is finally equal to 4x minus 3. And that is our answer. Question 9.2 says determine 9.2.1 dy over dx if y equals this. Now notice that everything is actually ready to be derived, so we can go ahead and derive. So dy over dx is equal to, and we'll say coefficient times exponent, so that gives us 20, and then exponent minus 1, which gives us 4. Same thing, coefficient times exponent, and that gives us negative 24, and then exponent minus 1, which is 3. And then 3 times the exponent of 1 on x is positive 3. And then that exponent minus 1 gives you 0, but anything to the power of 0 is 1, and 3 times 1 just stays 3. And that is our answer. Moving on to the next question. The next question, 9.2.2, we need to derive the function in the parentheses. So let's see. What is wrong with this right now? Well, it has a surd with x. That's a problem. If it had a surd with a number, just like square root 2, that's not a problem because that's just a number. So here we need to fix that. We need to ensure that there is no surd there. And then there is an x in the denominator, and that needs to come to the numerator. So here is what we can do. We can still keep writing dx because we have not derived yet. And then for this, what we're going to do is rewrite it like this. It's still a negative fraction, of course, but the x now will be written like this. We'll say the inside exponent of that x over the outside exponent, which is the number behind the surd. So that is 1 over 3 that we have there, and then that goes over 2. Okay, so that is it for that part. And then over here, this is squared. So one of the easiest ways to work with this is to, well, you could bring that to the numerator, or you could also just work on squaring it first. Okay, it's just a value squared. So 1 squared is just 1, but 3x all squared is 9x squared. Okay, and then we can move it to the numerator. So we have dx, and we still have this, which you can actually write as negative 1 over 2 x to the power of 1 over 3. And then this is going to be plus, and the x moves to the numerator. So we can just call this 1 over 9, and the x is in the numerator now, but because it moved to the numerator, its exponent would change to negative. So it's now negative 2. And there we go. And now we can actually derive. So we'll say coefficient times exponent. So that's going to give us negative 1 over 6x, and then exponent minus 1. 1 over 3 minus 1 is like saying 1 over 3 minus 3 over 3, which is negative 2 over 3. So negative 2 over 3. And then same thing here, coefficient times exponent, which gives you negative 2 over 9. And then exponent minus 1, which is negative 3. Okay, so to see how far we should go, we can just check the mark allocation. It's 4 marks. You get a mark for putting each of it in the standard form for it to be derived. So we get a mark there, 1, and then this one, finally putting it in that form, 2. So that will be 2 marks there. And then you get a mark for deriving it, okay, each of it. So that's 1, 2, 3, and 4. So this is fine. Okay, and at this point, you don't really have to rewrite it in a way that the exponents are positive. You can if you want to, but it's also fine to leave it at this point. Okay, so that is it for our answer here. And that is it for question 9, which is a total of 12 marks. Question 10 says the graph of h of x is equal to ax cubed plus bx squared is drawn. The graph has turning points at the origin, 0 and 0, and b, which is 4 and 32. A is an x-intercept of h. And the first question wants us to show that a equals -1 and b equals 6. Okay, so find the equation. Okay, so normally when two things are missing, you need two pieces of information to find that in an equation. But here is the thing. The origin is not very helpful here. We cannot go ahead and just start substituting this. Here's the problem. If you substitute the origin as x and y, you're just going to end up with an equation that says 0 is equal to 0, because you're saying that the y value is 0 and the x value is also 0, so that would just make these both to be 0. So not a very helpful point to put right now. But that's not a problem, because this point is a very important point and can be used twice. So here's how it can be used. It can first be used as a point and then as a turning point. So using that as a point, 4 and 32, we will simply take this, and in place of x and y in our equation, we will substitute that point. Okay, so we know that h of x equals ax cubed plus bx squared. And so in place of h of x, you can just straight away say 32 as the y value. And we're saying a multiplied by 4 all cubed plus b times 4 all squared. And then find out what this will be. So this is just 32 is equal to 4 cubed is 64. So that's 64a. And 4 squared is 16. So plus 16b. And this is what we have. Yes, they're in terms of a and b, but it's perfectly fine because we just need another equation in terms of a and b as well, and then we'll be able to find this. So the second way that we can use b being 4 and 32 is as a turning point. And here's the idea. If this is a turning point, it means that at that point, the gradient of this function is equal to 0. So let's start by finding the gradient of the function. We'll say h prime of x is equal to, and we'll say coefficient times exponent, which is 3ax exponent minus 1, 2. Same thing over here, coefficient times exponent is positive 2bx and exponent of 1 because we subtract 1. So this is what we have. This is the gradient of the function. Now we're specifically saying that the gradient of this function is equal to 0 at the point where x is equal to 4. So in place of x, we're going to substitute 4. So h of 4 equals 3a times 4 all squared plus 2b times 4. Now h prime of 4, the gradient at that x value of 4 is specifically equal to 0. So this is equal to 4 squared is 16 times 3 is 48. So that's 48a. And then 2 times 4 is 8. So positive 8b. And there we go. We have two equations in terms of a and b. Okay, so at this point, what we can do is make something the subject. What looks simpler to be made a subject here would be b, okay, in both equations. So I'm going to leave 16b on this hand side and then take that over. So 32 minus 64a. And then we can divide both hand sides by 16. So this is going to be b is equal to 32 divided by 16. You know that 16 plus 16 is 32. So that is 2. And then 64 divided by 16, that is negative 4, because that's negative. Okay, so negative 4a is what we have there. B equals 2 minus 4a. And we're going to do a similar thing on this side. So in this case, we'll just take that over the 48. So negative 48a is equal to 8b. And then divide both hand sides by 8 to make b the subject. So b is equal to 48, or negative 48 divided by 8 is negative 6, negative 6a. We can finally say that b is equal to b, and then we have 2 minus 4a equals negative 6a. And now we can solve for a. So we can take the negative 6a over, which becomes positive. And so that gives us a positive 2a is equal to, and the 2 gets carried over, which finally means that a is simply equal to -1 if you divide both hand sides by 2. And now that we know a, you can simply take that and substitute it into one of the equations of b to solve for b. So b, I'll now use this one because it's easier, is -6a. So in place of a, we say -1, and we can see that b is finally just equal to +6. And that is our answer. b equals +6, while a is equal to -1, as they have said. Moving on to the next question. Question 10.2 says, calculate the coordinates of a. Okay, so let's fill in our equation. We now know that h of x is equal to, and the a value is -1. So that's -x cubed, and then plus 6x squared. And a, looking at our graph, a is the x-intercept. Okay, so because it's the x-intercept, at that point, we know that y is equal to 0. So we'll say 0 equals -x cubed plus 6x squared. And now we have to factorize. So we can take out x as a common factor, or really -x, it's fine. So take -x, specifically -x squared, because that's what's common between the two terms, and open a bracket. And we are left with what? If you divide this by this, we just get x, and then +6x squared divided by -x squared, you get -6. And this is what we have. So it means that -x squared is either equal to 0 or x minus 6 is equal to 0, since they both multiply and give 0. Okay, so here, if you divide and then you square root, x is simply equal to 0, okay? And x is equal to +6. So we already knew that the other x-intercept and y-intercept, of course, was at the origin. So it means that this is the one that takes the 6. That is the +6. So the coordinates of a that they are asking for, a is simply equal to 6 and 0. We won't accept this one because we already have it there. And that is our answer. Question 10.3 says, write down the values of x for which h is increasing. So let's look at the graph of h. Where is it increasing? Well, to see what the graph is doing throughout, you always read graphs from the left-hand side moving to the right-hand side. Okay, like we read numbers and words. So looking at it like this, on this hand side, what is this graph doing? Moving from left to right. It is decreasing. And then we see that it starts to increase here. And then, of course, after it decreases again. So where it's increasing is within this region over here. Okay, so the values of x for which is increasing. Where does this start? What happens when a graph is decreasing is its gradient is negative all through. So what was happening here is the gradient of this graph was negative, and then it reaches a specific point. And at that point, which is the turning point or the stationary point, it stands still. It no longer increases nor decreases. And then after that, it starts to increase. Again, then it stands still and then starts to decrease. So we can see that the two critical values we need to be looking at are the x values of our turning points. So that is 0, the x value, and that is that x value of 4. So it is increasing all through when x is greater than 0 but less than 4. Remember, it is not equal to, because at that turning point, the graph is neither increasing nor decreasing. So that would be our answer. So x is greater than 0 but less than 4. And we move on to the next question. Question 10.3.2 says we need to determine the values of x for which h is concave down. Okay, so where is it concave down? Remember that all they mean by concave is how it is curved. Okay, it can either be curved up or down. There are two places on this cubic function where it's either going to be curved up or down. So we can see that all through here, it is curved up. And then here, it is curved down. Okay, so it's concave down here, and we just need to tell them where exactly that is in terms of x. To be able to find this, we need to find the place where the concavity changes. And where that changes would be at the point of inflection. That's where the concavity changes from concave up to down. So let's go ahead and find that first. To find the point of inflection, we will use the equation of our function, but we're specifically going to find out when not the first derivative, but where the second derivative is equal to 0. So we're going to say h prime of x, and find this first. So that's negative 3x squared plus 12x, and then find the second derivative. But we'll specifically find out where that is equal to 0. So deriving that, that will be negative 6x, and then plus 12, and of course the x falls away, is equal to 0. Okay, that's negative 6x is equal to negative 12, and if you divide both hand sides by negative 6, we can see that x is equal to positive 2. Okay, so we know that the concavity changes at x equals 2. So it will be concave down from x equals 2, not exactly at x equals 2, but after it. So this is where x is greater than 2. Okay, and that's what we're going to tell them. We'll tell them, finally, that means that x is simply greater than 2. That is where it would be concave down, and that is our answer. Moving on to the next question. Okay, question 10.4 says, for which values of k will this new equation, which still looks like the old equation, they just seem to have applied a -1. Okay, so it's still in the form of negative and then something cubed plus 6 and then something squared. Okay, but it just has a -1 now. So for which values of k will this equation have one negative and two distinct positive roots? We need the graph for this. Okay, so let's get the graph first and then see how we can manipulate it. Okay, so this is our graph, and currently this graph has just two roots, okay, one at 0 and one there that is positive, okay, at 6. But we first have to apply what they applied. They said -1, and they're saying specifically -1 to the x. When you subtract from an x, right, what you're actually doing is you're shifting this graph either to the left or the right. If it's minus, it's actually moving to the right. And if it's plus, it's moving to the left. So it means that they shifted this graph 1 unit to the right. So let's look at what would happen if we did that, because now we have to monitor the graph all through. Okay, so I'm going to highlight this graph first. And if we shifted 1 unit to the right, wherever that would be, it would look something like this. Okay, so clearly here we actually need the actual numbers. Here is what changes. Let's look at the things that would change. If it moves 1 unit to the right, then its new turning point here on the x-axis would be at 1 and 0. Okay, and the other turning point, it moved from 4 and 32. The y value doesn't change, the x value changes. It moved to the right, so it's now going to be at, let's call that b prime, or it will be at 5 and 32. So keep that in mind first. Not really that important yet because it's just the x that changes and we're controlling the y since that is k. Okay, so what else do we have to consider so that this can have exactly one negative and two distinct positive roots? From where it currently is, if it shifts up, you see how that will not solve our problem, because now it will no longer intersect with the x-axis on this side, and it only intersects here once. So that's only going to give us one root. So moving it up is not the option we need to go for. We need to go for moving it down. Okay. So do you see that as we move it down, right? There's this point where you move it down and it just has positive roots all through. That's one positive, second positive, and third positive root. So there is a little more information we need to know about this graph to manipulate it. And here's the thing, if we move it back to where it was here, we can actually see what we need to manipulate and what we need to consider. You see, shifting this graph to the right doesn't only affect these values, it also affects what the y-intercept would be. Here's the reason we need to consider this, because we are going to shift this graph either up or down. Well, we know it's down now, okay, because moving it up is not a good idea. But that changes this. And we can control the type of intercepts it will have if we knew exactly what that was. Once we shift it to the right, what is the new y-intercept? To find that, we can't just start guessing. What we could do is use the equation they've given us. Okay, so when they applied that shift, to find the y-intercept, you make x equal to 0. So substitute 0 in place of x, and let's see what that would give us. Well, technically, that's just going to be 0 minus 1, which is -1 times -1. Okay, if it gets cubed, it's still the same. So that's +1 there. And then plus, well, that's 0 minus, that becomes squared, which is +1 times 6, which is still 6. So that's 7. So it means that the y-intercept would be 7. Okay, here's the thing now. In order to ensure that, we're going to have 1 negative and 2 positive roots. We know we need to move it down, but we know this is 7. If you move it down, anything that is just like anything greater than 0, okay, just 1 unit down, for example, we don't have what we would need. If you move it another unit down, we still don't have what we need until this graph hits the origin on this side, okay? Until its y and x intercept is at the origin. So how far do we move this graph so that its y-intercept is now at the origin? Because the y-intercept is 7, you need to move it exactly 7 units down. If we move it 7 units down, then this is where it is. And then now, if you move it anything further than this, you see now that we're going to have 1 negative and 2 positive roots. Again, any more than that, 1 negative and 2 positive roots. But do we just keep moving this down? If we kept moving it down, it gets to this point where it sits on the x-axis. The local maximum is on the x-axis. And this is no longer the requirement. We need to ensure that it has 1 negative and 2 positive roots, but now it would have 1 negative and 1 positive root. Okay, so this is the limit. This is where we should not push it beyond. And what exactly would that be? Well, when it was here, when it was just like this, the y value was 32. We need to move it until the y value, right here, that local maximum's y value is here, and that y value will be at 0. So don't move it anything more than 32 units. Okay, so here's another graph just to show that. We're just going to move it down anything more than 7 units, because once we just move it just like more than 0 units, it doesn't help. But anything more than 7 units, but nothing more than 32 units. Now you can already see that we have a minus here. So that's already accounting for the downward shift. So we can just basically tell them that k just needs to be a value that is greater than 7, but no more than 32, but less than 32. And if we do that, then you'll see that it will always have 1 negative and 2 distinct positive roots. And that is our answer. And that is it for question 10. Question 11 says, after traveling a distance of 20 kilometers from home, a person suddenly remembers that he did not close his tap in his garden. He decides to turn around immediately and return home to close the tap. The cost of water at the rate at which the water is flowing out of the tap is 1 rand 60 cents per hour. Okay, so looking at that, depending on how long this journey takes, he's gonna spend a specific amount on water, right? The cost of water. And then they tell us the cost of petrol. So we're looking at 2 costs. The cost of petrol is 1.2 plus x over 4,000 rands per kilometer. So this one is dependent on distance. Okay, so depending on that distance, where x is the average speed in kilometers per hour. And now the main question asks, calculate the average speed at which the person must travel home to keep his costs as low as possible. In calculus terms, what they're really asking is, calculate the speed at which the cost is a minimum, as low as possible. Okay, so to better understand this, let's just have a visual diagram. So this person traveled from home, and as they were traveling, they eventually get to some place, and we know that that place is 20 kilometers away. And when they get there, they realize that the tap is left open. And so this person decides to turn around immediately. Now we need to consider whether they are counting the distance traveled from home to this place where they remembered and then back, when the person eventually gets back home. So let's just read into that. Do you see that they specifically say he decides to turn around immediately and return home to close the tap, okay? And then they speak about the costs. And the question is to calculate the average speed at which the person must travel home. Okay, so we are only considering the journey home and not the journey to this location where they remembered. Okay, good to know. So it's only 20 kilometers that we're going to consider as the distance traveled because we're just considering that journey home. Okay, and now let's just see how we're going to solve for this question. In calculus terms, they're really asking us to find the speed. So in other words, our equation, whatever we're going to find, is going to be in terms of the speed. Okay, and they told us that the x is the average speed. So it will be in terms of x. But it's the speed at which this cost should be as low as possible, at which this cost is the minimum. So the first thing is we need to find out how we can express the cost. There are two criteria that they've given us here, or two factors. The cost of water and the cost of petrol. Okay, let's put those down. So we're looking at the costs. We're saying this is how we're going to find the cost. So cost of water, first of all, and they told us that the cost of water is 1 Rand 60 cents per hour. Okay, so 1 Rand 60 cents per hour. So if we could find out exactly how many hours it takes him to get home, then that would solve the problem here. We'll find out exactly how much the water would cost because we would know how long it took him. Okay, and then we're going to, of course, add this to the cost of the petrol. So these are the two costs that we're going to consider. And we know that the petrol is calculated as 1.2 plus x over 4,000. And this is in rand per kilometer. So if we find out the distance, the kilometers, this one is quite simple. We know the distance traveled, then we can find this. Okay, so we're just trying to find these costs separately. So with this one, it's fine because this is in rands per kilometer. We know that his journey takes 20 kilometers. Okay, so to find out the full cost of petrol, you would take this is the money per kilometer, and we'll just take that multiply by 20 kilometers because it took him exactly 20 kilometers to get home. It's kind of like if it said, if we had the value of x and we said it's going to cost him 5 Rand per kilometer to get home, then how much did it cost him? How much was the petrol? It would be 5 Rand times 20 kilometers. Okay, that's an example. Okay, so with that being said, now we know how to find that one. How do we find this? How do we find the full cost of water? It's 1 Rand 60 per hour. How long did it take him to travel? Okay, so we're going to have to look at the information we have been given. We know some info about this journey. We know the distance that it took was exactly 20 kilometers. We know the speed. We may not know the actual value, but they told us that the average speed is x. So we know the speed. And so we're going to use this to find out. We need to find out how long it took him, the time. Okay, so we can find out what was the cost of water. So to find this, we can use the diagram on speed, distance, and time. You can use DSTV to remember it. Okay, and now we're trying to find the time. So we're saying time is equal to distance over speed, and then that is going to be 20 over x. And there we go. We have everything we need. We have the distance, the speed, and the time. Okay, so let's go ahead and just put the full cost. So this is how the cost is going to be calculated. So we will say 1 Rand 60 cents per hour. So we need to find out now the full cost of water. We know it took him how long? 20 over x hours. Okay, we don't know what x is, but it's still the time. So we're going to say times 20 over x. Okay, we know it is in terms of hours because the average speed is in kilometers per hour. Okay, so the cost is this. That is for the water. And then we're going to add this to the full cost of petrol. And that's going to be yeah, these are in rands. I don't really have to put the odd, it's fine. 1.2 plus x over 4,000. And then you need to say multiplied by, so with this one, I'm just going to put it in brackets like that. Then multiply by the amount of kilometers that it took, okay? Because this is per kilometer. Remember the 5 rand example? Okay, so per kilometer, and we know it took him exactly 20 kilometers to get home. So that's 20 kilometers. There we go. And this would be the cost. That's the cost that they were referring to here. Then we're going to find the speed at which this cost will be a minimum. So let's simplify our cost equation. You can see that it's already in terms of x. So we might as well just call it c, okay, c of x. It's in terms of x. Okay, so let's go ahead and calculate this. So we're saying 1.60 multiplied by 20 over x, okay? So times 20 is 32. So this is 32 over x. And then plus, and we're adding here. So this is 2 terms that you have multiplied by 1 term, so you need to FOIL out. So those will multiply in, and we're saying, what is 1.2 times 20? And that is 24. So that just gives us 24. And then 20 times x over 4,000. 20 over 4,000. And that is 1 over 200. So we're going to say plus x over 200, because that is 1 over 200 and then the x. Okay, so this is what we have. And we are going to really just find the minimum value of this. So let's see how we can do that, because the whole point is to find the average speed, which is x, find x for which this is going to be at a minimum, at the lowest that it can be. So to find the minimum value, this is now an optimization question. To find that minimum, remember, it works the same thing as the turning points, okay? If you have, let's say a parabola, for example, some sort of curve, and you're trying to find that minimum value, it is that place where the gradient is stationary. So that's the whole point of it. We're just looking for where the gradient is standing still, okay? That change between increasing and decreasing, that change in gradient. So we will find the gradient of this function simply by deriving it. But as you can see, this is not ready to be derived because you have an expression with x in the denominator. So we're going to move that to the numerator. So this is now c of x is equal to 32. And then when we pull the x up, it becomes x to the power of -1. I'll just write this here after. And so this one, we can just rewrite it as there's an invisible 1 in front of the x. So that's 1 over 200 and then x. And then this is just plus 24. Okay, so this is what we have. And now we can finally derive. So we're going to say c prime of x is equal to coefficient times exponent is -32x. Raised to the power of exponent -1 is -2. And then coefficient 1 over 200 times exponent of 1 on the x is +1 over 200 again. But then exponent -1 is just going to be 0. Anything to the power of 0 is 1. And so 1 over 200 stays the same. And of course, if you derive a constant, it's equal to 0. And now to find that minimum value, you must make the gradient equal to 0. So this is -32x raised to the power of -2 plus 1 over 200. And then we can transpose this. So that's going to change the sign of the 32. That is 32 now, x raised to the power of -2. We might as well pull that x down to the denominator. So now it's x to the power of +2 is equal to 1 over 200. And now we can just solve for x. You could cross multiply, and that's going to be x squared is equal to 32 times 200. Okay, 64. So that's going to be 64, and it is 6,400. And then if you square root both hand sides, we know that the square root of 64 is 8, so this would be 80. Okay, so of course it's the positive and negative. Okay, but in this situation, consider what x is. X represents the speed. So the speed is not negative, it's positive. Okay, regardless of whether you ever get a negative value for the speed, you have to consider the absolute value to account for the speed. So x is equal to 80. and that would be x. And what is it in terms of? Is it in terms of anything? Okay, it's in terms of kilometers per hour. So that would be the speed. This person needs to travel home at 80 kilometers per hour so that his cost is at the lowest that it can be. And that is our answer. Question 12 says, 12.1, A and B are independent events. If it is further given that the probability of A and B is 0.3 and the probability of only B is 0.2, then 12.1.1 says, are A and B mutually exclusive? Okay, motivate your answer. So the thing with mutually exclusive events, they are events that do not intersect. Okay, and so because they do not intersect, they don't have an intersection, meaning where we have probability of A and B, this should be equal to 0. Okay, but from the information they've provided, you can see that probability of A and B is 0.3, so there is an intersection. And so because of that, this is actually not mutually exclusive. They have an intersection. So we can tell them that the probability of A and B, as we can clearly see, is not equal to 0. Therefore, the events are not mutually exclusive. Okay, so but really this would be the reason. So A and B are not mutually exclusive because probability of A and B is not equal to 0. Okay, so we can say no, A and B are not mutually exclusive because the probability of A and B is not equal to 0. And that is our answer. Question 12.1.2, A says determine the probability of only A. Okay, so let's look at the relationship between how these would work. Okay, so in the Venn diagram, you have two circles, and these two circles, they intersect. We know that now. So this is A and this is B. Okay, now we specifically know, just so that we have enough space to write in there, we know some of these now. We know the probability of only B. Now, when it's only B, it means it's not going to be included in the circle of A and B. It's not going to be here. It will just be in only B. So we know that that is 0.2. So that's 0.2. And we know the probability of A and B, the intersection of them, which is 0.3. So how do we find the probability of only A? Okay, let's use what they told us. They told us that they are independent events. Okay, so A and B are independent events, and this is how independent events work. If events are independent, then the probability of A and B is equal to the probability of A multiplied by the probability of B. Now, these are not only A and only B. They are the entire circle of A and the entire circle of B. So we know what A and B is. That is 0.3. So 0.3, and we say is equal to, we don't know what the probability of A is. So long we'll just leave that open. And we're saying multiply by the probability of B. We actually have that. The probability of B means the entire circle of B, meaning we would have to add the 0.3 and 0.2, which give us 0.5. So that's 0.5. And now you see that to make probability of A, the subject, you just have to divide both hand sides by 0.5 so that it's gone. And so that's just 0.3 divided by 0.5. And so the probability of A is equal to, but that's going to be, so 0.3 divided by, this is a half, divided by a half is going to be 0.6 because it's going to make a double. So that is 0.6. That's what we have as the probability of A. But this is not the probability of only A. Okay, the probability of only A would be this part over here. But the probability of A is this entire part. So you see that to find the probability of only A, we simply just need to say the probability of A minus the intersection, which is the probability of A and B. Okay, now we already got the probability of A, so that can be found. So we can just say the probability of only A would be equal to 0.6 minus the intersection of 0.3. And there we go. The probability of only A is simply equal to 0.3. And that is our answer. And then B says we need to find the probability of not A or not B. Okay, let's just look at that Venn diagram. So we know that we have these two circles intersecting, and this is A, this is B, and we also have the numbers. Okay, we've got that probability of A only. Okay, so that's what our Venn diagram looks like. 0.3, 0.3, and then 0.2. Okay, so this is what it looks like. Of course, we have an outside, but I'll just call that X for now. Let's see whether we need it or not. So they want the probability of not A or not B. When you see or, this really just means to add. So the probability of not A, everything excluding anything in the circle of A, that would be all here, right? And whatever that outside is. Okay, so clearly we need to find out what that is first. So before even going into this, let's find out what that is. So to find that, you see that everything in the Venn diagram will add up to 1. So to find the outside, we can say X is equal to 1 minus everything in the circle. So it's minus 0.3 and 0.3 and minus 0.2. So minus 0.6 like that is already 0.4, and then minus 0.2 is 0.2. Okay, so we know what that is now. We know that the outside is 0.2. Okay, so we need to find out the probability of not A or not B. So not A would be everything excluding anything in the circle of A. So that is over here like this. That's not A, also including that. And then or not B. So what we have so long with that probability of not A or not B is we so long have 0.2 plus 0.2, okay? And then not B would be everything excluding the circle of B. So that would be everything here, okay? And of course the 0.2, but we already added that, so we don't have to add it twice. So that will be the 0.3. Okay, and so that would give us, that's 0.4 plus 0.3, which is 0.7. Okay, so that would be the answer. Probability of not A or not B is 0.7. Another way that we could have also looked at this is to think about, well, it's just based on what is highlighted. Okay, so what is highlighted was all of this. So we knew that that's what needed to be included. So we could have also said, we can just see that we just need to exclude the intersection. So if you take the entire Venn diagram, which would be 1, minus the intersection, you would also get that. Okay, so there we go. Okay, and that is it for that question. Question 12.2 says, a teacher has 5 different poetry books, 4 different drama books. Okay, so let's go. 5 different poetry books, 4 different drama books, and 3 different novels. She must arrange these 12 books from left to right on a shelf. Write down the probability that a novel will be the first book placed on the shelf. Okay, so there are a total of 12 books. The probability that it's going to be a novel that is placed first on the shelf would simply be how many novels there are versus the total number of books. There are exactly 3 novels over the total 12 books. So this is 3 over 12, which simplifies to, they both have a common factor of 3. So this is just 1 over 4. And that would be our answer. So the probability that the novel would be first, of picking a novel really, would be 1 over 4. Okay, moving on to the next question. Then question 12.2.2 says, calculate the number of different ways these 12 books can be placed on the shelf if any book can be placed in any position. Okay, so the fact that they already put it in categories, you would think, okay, maybe we have to use grouping, but they can be put anywhere, okay? Any book can be placed in any position. So you have a total of 12 books. You're allowed to put them anywhere, meaning the first book is going to have 12 different options to be placed in. And then the second one will have, because the first book has been placed down, the second one will have 11 options, and the third will have 10 options, and then the next one will have 9, the next will have 8, and so on, all the way to 1. So you can see that this is simply 12 factorial. So let's find out what 12 factorial is. 12 and then factorial with the, is, that's going to be 479 million and 1,000. Okay, so this is how it goes. 479 million, 001, and then 600. Okay, so there we go. 479 million, 1,600. And that would be the total ways. Moving on to the next question. Question 12.2.3 says, calculate the probability that a poetry book is placed in the first position, and then the 3 novels are placed next to each other, and a drama is placed in the last position. Okay, so we need to ensure that a poetry book is placed in the first position. And then 3 novels, the 3 novels are placed next to each other. And then a drama is in the last position. So remember that we have 12 books in total. So there are 12 placements or 12 spots that we have. And let me just represent that first. Okay, 12 spots on the shelf. And they say a poetry book is placed in the first position. So how many poetry books are there? They told us initially there are 5 poetry books, 4 dramas, and 3 novels. So in the first position, we have, remember these are different poetry books. They're not the same poetry book. So in the first position, poetry book 1 could be here, or 2, or 3, all the way to poetry book 5. So we have exactly 5 choices here. And then we also know that the 3 novels are placed next to each other, okay? But there's also another placement here that we cannot change, and that's the drama. The drama must be placed in the last position. So in the last position, how many dramas are there? There are exactly 4 dramas. So it means that in the last position, there can be the drama book 1, drama book 2, 3, all the way to 4. So there are exactly 4 choices that we have here. Okay, 4 choices of books that we have there. And now we need to ensure that the 3 novels are placed next to each other. So the 3 novels are next to each other. So it does not have to be next to each other in this order, but this is just an example. So novel 1 could be here, novel 2, and then novel 3. So they'll be next to each other. And so they really just form a group. So let's just put them like this. They form a group. Okay, now we would have to look into that group just to see what's going on. So, and then we'll have the remaining placements. So let's just see how to calculate this. We would say 5, okay, multiplied by, and then let's figure out how these novels are going to be placed. They don't have to be placed in this order that they're currently in. It does not have to be novel 1, 2, and 3, okay? Before we place anything down, first, we will notice that novel 1 will have 3 spots, okay? It could either be here, it could be here, or it could be here. Of course, this does not mean that they are restricted to just this place here. They could be anywhere as long as they are in 3 positions, 3 consecutive positions, okay? And they're grouped together. So that would, of course, also mean that they could be placed here or here even, okay? But we'll account for that soon. But first of all, let's just account for the group. So we know that novel 1 can be placed in either this position over here, or here, or here. So novel 1 would have 3 places, 3 options to be placed in. And then once novel 1 has been placed down, novel 2 will have 2 places to be placed in, okay? 2 options. So that's 1 and 2. And then once novel 2 is placed down, then novel 3 will have exactly, so that's times 2. And then novel 3 will have exactly 1 place. Okay, only 1 spot left since they need to be placed next to each other. Okay, and so that creates 3 times 2 times 1, which is 3 factorial. So we see that on their own, they create 3 factorial. Okay, the total ways that they can be placed as a group is 3 factorial. Okay, so we're done with that. And then looking at that last place, because it's the other thing that we have, the 4. Okay, since at the end, we need to ensure that there is a drama placed there. Okay, so that's the 4. So we're really just saying times 4, because we can either have drama 1, 2, 3, or 4 there. Okay, so that's what that looks like. And now we have to account for the rest of the other books that will be there as well. Now, let's just see how many spots we have available or what can really move around. So all through here, we'll have different books because remember, we still have 12 books. So the remaining books have how many spaces left to sit in. Okay, the remaining books have, that's book 1, book 2, all the way to 3, 4, 5, 6, and 7. But now we can finally take into account that these 3, they do not have to be in this particular position. They could be here, for example, okay, or here, or here. Now, to allow them move around, meaning as well, these are the books, they don't have to be in this position as well. So to ensure that they're still able to move around like that, we can see them as a group of their own. Just keep in mind that these 2, we cannot change that, okay? Those ones do not move because we know that we need to have a poetry book here first, and in the last position, there needs to be a drama. So those ones would not move. Okay, now to ensure that these ones can move around and they don't have to be placed in the exact same way that they are, we can look at them as groups of their own. Okay, so this would form the first group. That would be the second group, okay, so that it can move around. For example, book 1 can go over here instead. And then this will just shift over. Okay, so that's the first group, second group, third, fourth. Okay, so how many groups will we have in total? Including this, we'll have exactly 8 groups. So we need to ensure that they are able to move around through here, but they cannot take the first and the last position. Now, to ensure that it's exactly the same way as we've been working with all of these, especially this part over here. See how when we knew that we had 3 places that they could sit in, since they have to be placed next to each other, we considered it like this. The first one has 3 different options to sit at. And then once one book is seated, the second book would have 2 different options to sit at. And then once that book was placed, and then the last book would have exactly just 1 option to be placed in. It's the same way we will consider these groups. We know that there are exactly 8 groups, yes, but the first group has 8 different options to be placed in. This does not necessarily have to be here. It could be in this position. See how it could perfectly just fit in there? All that would happen is this book will just shift over and take the position of this group, okay? It could also be in this position and that position. So that will be 8 different positions it could be placed in. And then once that is placed down, then the second group, the second book would have 7 different options to be placed in. And then the third one, 6 different, and then 4 and 3 and 2 and 1. So that again is 8 factorial. Okay, so this would be the total ways. But let's just focus on the question. The question is specifically calculate the probability that a poetry book is placed, okay? So calculate the probability that this happens. So it's this over the total outcomes. And we know that if we didn't make any restrictions to these books, we have exactly 12 books. So the total ways we can place all those 12 books would be 12 factorial. That would be that first question that they asked us here. Okay, so we would just say that the probability would simply be equal to 5 times 3 factorial times 4 times 8 factorial all over 12 factorial. And let's go ahead and see our answer. Okay, and that is exactly 1 over 99. And we can leave it as a fraction, that is fine. And that is the answer. That would be the probability that this kind of situation could happen. And that is it for question 12. Okay, so that is it for this paper. Hope you guys enjoyed it, and I will see you guys in the next one. Bye.